Circadian rhythms and hormonal harmony, a delicate synchronization. Hormone regulates various bodily function including growth, metabolism, immune, and their secretion is influenced by circadian rhythm. So hormones regulate circadian rhythm and circadian rhythm influence their secretion. There are multiple hormones which are associated or which function as per the circadian rhythm. The first one is cortisol, secreted by adrenal gland. It follows a diurnal rhythm. It tends to peak in the morning, helping to wake you up and provide energy for the day. As the day progresses, the cortisol level gradually declines, reaching the lowest point in the late evening. That promotes sleep. Melatonin. It is secreted by pineal gland and plays a key role in regulating sleep-wake cycle. Melatonin level begin to rise in the evening, a couple of hours before bedtime, to help maintain sleep throughout the night. In the morning, as the light increases, melatonin production decreases. Growth hormone is primarily released during the deep sleep, particularly during the first few hours of sleep. The timing of its release is closely tied to circadian rhythm, with a peak in the first half of night. Growth hormone is essential for tissue repair and growth. Thyroid hormones, TSH, thyroid stimulating hormone, levels typically peak during the early morning hours, leading to increased production of thyroid hormone that help regulate metabolism and energy level throughout the day. It tends to peak in the late morning and decrease in the evening. Sex hormones as testosterone levels are highest in the morning, while estrogen levels vary depending on menstrual cycle in women. Insulin is not primarily regulated by circadian rhythm, but disruption in circadian rhythm is shown, especially with disruption in sleep, can lead to insulin resistance and disrupted glucose metabolism. Leptin and ghrelin. These hormones are involved in appetite regulation. Leptin signals fullness that tends to peak during the night, whereas ghrelin stimulates hunger, it peaks during the day. This can help explain why appetite and food intake patterns follows a diurnal cycle not to be disrupted. Adrenaline and noradrenaline. These stress hormones exhibit circadian variation with higher levels typically in the morning to help mobilize energy and prepare the body for the day's challenges ahead. Circadian rhythms and neurons. The relation between circadian rhythm and nervous system is complex but plays important role in maintaining overall health and well-being. Circadian rhythms and neurons are intricately connected, with neurons serving as biological machinery that drives and maintains the body's internal clocks. The primary and the most important one here is the suprachiasmatic neuron, which is also called as a central biological clock placed in hypothalamus. It orchestrates timing of circadian rhythm through light or photo entrainment. Circadian rhythm influences the release of neurotransmitters like dopamines and epinephrine. These neurotransmitters play important role in mood regulation, alertness, and cognition. Circadian rhythm disruptions through exposure to blue light at night or through a disruption of wake-sleep cycle through any reason can impact the release of these neurotransmitters and may lead to mood swings and sleep disorders. Melatonin is a very important hormone whose release is controlled by suprachiasmatic neuron. It is a hormone released from the pineal gland through circadian rhythm. It prepares the body for sleep. It promotes the calmness of nervous system and its relaxation. Autonomous nervous system is modulated by circadian rhythm with oscillation between sympathetic and parasympathetic functions. There is a change in sympathetic fight or flight Two, parasympathetic is rest and digest activity during day and night. Synaptic activities of the suprachiasmatic neurons are very important in maintaining the circadian rhythm, as shown by the experiments performed on rodents, wherein the disruption of the circadian rhythm, especially by exposure of light during the night, disrupted the synaptic activities of the suprachiasmatic neuron. It desynchronized the circadian rhythm, leading to the rodents showing changes in their behavior, cognition, and mood. And of course, the midnight snap can also, or the tendency to feel drowsiness towards the mid afternoon, is also linked to the circadian rhythm and neurons. Since early morning, our circadian rhythm is picked up and activates the nerves, and the optimum activity of the nerves is recorded at around 10 a.m. to 11 p.m., followed by a resting period for the nerve that also coincides with a post lunch is 2 p.m. to 3 p.m. There is a lull, there is a dimness of the nervous system. By evening, the sleep hormones gets activated, leading the drowsiness. So the midnight lack of activity faced by both teachers and students can be somewhere um, credited or handed over to our circadian rhythm.